My name is Gergely Sipos. I'm Head of Services, Solutions and Support Department at the EGI Foundation, and I'm happy to give you in this EGI introduction presentation in the next half an hour or so. In this presentation, I will first talk about what EGI is, who we are, what are the different stakeholders. Then I will talk about what we do, what are the services and support that we deliver, what kind of technologies and services this entails. I will try to show you real-life examples as much as possible to make everything realistic. I will then briefly talk about how EGI and the European Open Science Cloud relate to each other, which is a recurring question lately. And during the overall presentation, I will have these yellow boxes on the slides, which indicate you sessions from the EGI-21 conference that link to that particular topic of that slide. So if you are interested in learning more deeply about a specific topic, then please come back in the next days and listen to those sessions. So let me start a story from the Large Hadron Collider, which probably many, if not all of you, already heard about. That's a huge construct underneath the ground near Geneva at the CERN facility. And that huge accelerator required a massive distributed IT compute infrastructure in the late 90s, early 2000s. And EGI actually grew out as a generalized version of that compute setup that the CERN established for its computing physics experiments. And around 2010, we became EGI, a European infrastructure that supports research and innovation in general, not just physics, but all sorts of disciplines. And in the past 11 years, we grow both in terms of the diversity of sciences that we support and the diversity of technologies that our infrastructure include. In 2010, when the EGI infrastructure was established, we came with a vision that all researchers should have seamless access to services, resources, and expertise that they need to collaborate and conduct world-class research and innovation. And therefore, the EGI Federation was established with the mission to deliver open solutions for advancing science through compute and data analytics services. As part of the EGI Federation establishment, one of the first steps was to establish the EGI Foundation, which is a non-for-profit organization based in Amsterdam, tasked to coordinate the work of the Federation and to serve international research and innovation together with its members. On this map, you can see the current membership landscape. We have 27 members participating in this pan-European endeavor. The blue countries and blue institutes on this map represent either national infrastructures or international communities through a given scientific organization. The orange countries and institutes represent the so-called associated, so more lightweight or more entry-level participants. And together, these countries and institutes work on advancing science and innovation by bringing together IT services and expertise for the sake of advancing innovation. Overall, the EGI Foundation, as I mentioned, provides the coordination for this work. This is just a snapshot of the current membership. You can see that each of the participants, for example, Belgium, each of the participants has a participating institute, which is typically represents an entity, very often a national infrastructure or an international scientific community. For example, an example for the latter is the EISCAT Institute in Sweden, representing the international EISCAT consortium, which is also has its own council representation format. If you're interested in listening to examples of how such NGIs or participants operate or scientific institutes operate, please listen to the keynote talks that we will have tomorrow or on Wednesday or on Thursday as a closing keynote. The overall federation is organized practically in 3 layers. The EGI Foundation as the coordinating institutes works directly with the EGI Federation members. These Federation members bring together their IT capacity, clusters, cloud services, storage services, the different physical hardware elements, brings together technological elements, software tools that are hosted on those platforms, and the know-how that users need to fully harness the benefits of those infrastructures. Members of the Federation work in the broader context as part of the EGI community, which is the broadest context that we define in EGI, including all the providers and all the user communities that participate in this endeavor, including even non-council participant members that we have linkage to through different types of agreements around the globe. These global partners are shown on this next diagram. We have partnership agreements with similar e-infrastructure providers around the globe. Some of them are representing a single countries, for example, in Compute Canada, or Latvia, or Georgia, and Moldova. Others represent a larger area. For example, the Latin America agreement covers multiple countries. The work that we do together with these non-European partners is aligning technologies, aligning infrastructure approaches that help global science harness IT services, both in Europe and in those other continents and countries. On Friday, as part of the conference, we will have a second Global Open Science Cloud workshop where we bring together some of these partners to discuss the next steps in building global collaborations. And what EGI members and partners, the whole EGI community, delivers together is, first of all, a set of services that scientific communities can use. You can see this service portfolio on this slide, and it's segmented into different areas. The first is the compute service area. We offer different style of computing services, cloud computing, container, high throughput, and workload management that fit to different types of use cases, whether it's more batch computing, largely parallel applications, or interactive applications that require more interaction with end users. We have storage and data services consisting of an online storage service that's suitable to make data interactively available for live consumption, a data transfer service that can help the user bring large data sets into the infrastructure or between the different sites inside the EGI infrastructure. And we have a data hub service which can cache data and move data between the user side and between the different infrastructure sites in a more ad hoc user-driven manner. We have a section for application services or more user-level services. On one hand, we have a so-called application on-demand service, which is an online environment through which scientific applications can be hosted and exposed to end users as hosted services that can scale on large-scale compute and storage systems in the backend. We have a notebook service that's an EGI version of the Jupyter Hub technology, making Jupyter-based online computing and scripting available on top of the EGI cloud and container and storage resources. We have a security service called Check-in that is basically the user authentication and authorization layer used both in the EGI services and also connectable to third-party services to make coherent user authentication and authorization possible across sites, across countries. And last but not least, we have a training set in the portfolio, which consists of FITSM training, which is a lightweight IT service management standard, an ISO 27000 training about information security, and a training infrastructure, which is a cloud-based compute and storage infrastructure that we use and we can offer as well to trainers and educators to run any kind of software course in a cloud environment. All the documentations about the technical services are available at the docs.egi.eu, and through the whole conference there are a number of sessions and many talks that are dedicated to certain elements of this portfolio. So if you want to learn more deeply about the technical capabilities, about the actual user examples, then please attend those sessions. The largest part of EGI, or the most talked about part of EGI, is of course the compute environment. And we basically have two types of compute environment: the so-called high throughput compute environment, which directly grow out of the Large Hadron Collider, the CERN infrastructure that I started my presentation with, and a federated cloud environment, which is a quite dynamically growing environment, federating OpenStack clouds together and making them into a seamless integrated environment for international science. Let me talk a bit about how can a user or a user community access these services. What are the access policies and conditions? The EGI Federation sites are contributed by providers from academia, a few from industry, and each of these work with different types of access policies. But overall, there are three types of access policies that we offer in the infrastructure. One is the so-called wide access, where the users can freely and without any limitation basically access the services that are offered by the EGI resource providers. The resources that are offered with wide access are typically constrained by, for example, the size of the capacity or the technical capabilities of the capacity. However, they are often the first stepping stone for a new user to try out certain capabilities before going into the larger or more long-term usage of EGI. The typical examples of the wide access resources in EGI are those cloud resource pools that are made available for application porting and application integration purposes for a limited period of time, typically 6 months, or a dedicated instance of the EGI Notebook service, which is open for any user. The most typical policy used in EGI is the so-called access-based policy, which includes any sort of policy that the resource provider, the data or compute center, is using on top of its resource. Typically, these policies are defined by the funding agencies that operate or finance the work of that academic center, and therefore the policy, for example, restricts access to a certain compute resource for a certain disciplinary area or for certain nationalities. So 2 examples here. There is a resource pool populated by multiple high throughput compute providers from EGI, and this resource pool is assigned for biomedical researchers. So only those users who are working in the biomedical domain are eligible for access. Another example is that our data center or compute center for from INF and Bari, from IN2P3 in France, and from Ulagbin in Turkey, provide together cloud resources for Swedish virtual research environment called the National Bioinformatics Infrastructure in Sweden, in order to enable the users of that environment. And the third type of access policy is the so-called market-driven, which basically a fee-based access, which can be, for example, the FITSM training offered by the EGI Foundation. This is offered on a for a payment. Whether that payment is paid by those who attend the course, or the payment is paid by a project, and then the attendees can attend for free. That's another aspect, but there is definitely a financial transaction here. Another example is that some of the cloud allocations or cloud resource pools are assigned on a pay-for-use basis for certain communities or for certain projects. And here is one example with Xprevia from the Earth observation science domain. If we look at the full spectrum of who is using EGI today, we can identify 4 groups of users. On this diagram, these 4 groups are mapped on this on one axis. You can see the name of the research of that particular group. The other y-axis is showing the individual size of the size of an individual element in this group. In the first part, you can see the research infrastructures, which are large international constructs that require services for the very long term for a large number of users from a given scientific disciplinary area. So WSEG that I mentioned earlier is from physics, but there are similar large-scale scientific research infrastructures in all disciplinary domains. This is a very important user base and partner base for EGI, given their huge size, their importance, as well as long-term lifetime. The second group are the multinational communities, very often R&D projects, for example, from Horizon 2020, that require the services that the EGI Federation offers. They require these services typically for 3, 4, 5 years in order to enable, for example, certain simulations, set up certain environments, operate certain data analytics capabilities. The third group are industry, or is industry and different SMEs, for example, that want to do piloting activities, business development activities together with EGI. The third is the so-called long tail of science, the individual researchers or small research groups that don't have in-house capacity and would like to use EGI resources in order to carry out some quite time-limited simulation or data analysis work. There are, again, quite a few and diverse sessions during the next few days where you can listen to stories from each group. I just mentioned 3 of those here. The scientific keynotes include representatives of the large-scale research collaborations. User experiences with the EOS Compute platform will be a summary talk tomorrow about the different user types and usage practices that we envisaged on EGI in the past 9 months. And there will be, for example, a specific session talking about projects that are active in policymaking and use EGI services for that purpose. How do we serve these large-scale international collaborations or even the Horizon 2020 projects? This diagram shows you this workflow that we apply, and it goes like this. The EGI Federation consists of different independently operating service providers that are brought together by the EGI Federation into a coherent whole, which is offered by the EGI Foundation as a negotiator of services for the international project or research infrastructures or communities. Those communities can approach EGI in order to request some services, knowing the type, the size, or the cost and the availability constraints that they have. That kind of data is negotiated by EGI on behalf of its members, and we basically do a matchmaking between the demand, the constraints, and the available services, and also preferences that our providers have. This negotiation of services results in a so-called service level agreement, which defines what kind of services, how much of them, and for how long our members can and will deliver for this project or community, and results in a number of operational level agreements that the EGI Foundation has with the selected members who participate in that given service level agreement. The service level agreement ensures that the customer gets what's needed for the simulation or for that particular piece of work. The operation level agreement ensures that we meet the agreed targets on a continuous basis. This is strengthened further later on as the usage happens with the so-called regular satisfaction interviews and with regular service delivery reports that we produce for the community or the customer. One example of how this works in practice. We work with the Panos project, which is a cluster of research infrastructures from the proton and neutron sciences domain. The cluster itself includes 6 research facilities, all operating a photon or neutron source that generates tremendous amount of data for each experiment for the users. And we formed a partnership with Panos to set up a resource pool or a data space basically for them inside EGI that combines 4 types of services from the EGI portfolio. We have a cloud compute service with CPUs and storage. We have a data hub service that is connected to the 6 facilities and that can read data sets from the facility storages into this data space, storing the data on the EGI cloud resources, exposing the data through notebook interfaces for the scientists who can interact with the data through this command line and through these scripting interfaces in order to do some customized data analytics and visualization. The user login happens through the EGI check-in system, which is connected to the so-called umbrella identities that are operated by these photon and neutron research communities already. This data space combines these EGI services and puts an extra layer between the facilities and the end users, and this extra layer operates as a caching and compute system that can empower the users to combine data across multiple facilities and to do simulations and large-scale analysis that wouldn't be possible just by relying on the IT facilities at the individual research infrastructure nodes. On Wednesday, we have a workshop talking about data spaces and data ecosystems where you can hear about examples of similar data space setups from EGI and even from beyond. Another example of how we use this SLA and OLA mechanism. This research infrastructure example is coming from marine observation from the EMSO research infrastructure. EMSO is responsible for collecting different types of data about the sea bed and about the seafloor columns, observing both the ecosystem as well as different physical parameters of the ocean and the water itself. These regional facilities bring data together by different APIs and different data staging systems, push that data into an EGI cloud allocation, which is secured by EGI through an SLA from two of our members. One is a compute center in Spain, CESGA. The other is a compute center in Bari from INFN. And these two providers are brought together under the single SLA by the EGI Foundation to deliver the required cloud compute capacity, as well as the support that comes with that for the EMSO research infrastructure. The research infrastructure team operates different high-level virtual research environments, portals, different dashboards, data analytics systems in the cloud, and as new data comes in, makes new real-life monitoring and data push mechanisms towards the users. And here are some screenshots of the service level agreement and the operation level agreement that we have with the two centers and with EMSO. You can see here that it details the capacity that we allocated for them from the two centers, splitting them into compute and storage capacity. And the second screenshot shows you some indication of the type of service hours and the response time for the different incidents or different user requests that we handle. Let me move on to another example, which is about an open access service. I mentioned this already, the EGI Notebooks, and it has a deployment that is open for anyone. You can go to this link, you can request access, and within a few hours, my colleagues will approve this without checking your background, your affiliation, whether you are from industry or academia. This free access for the notebooks provides 2 CPUs, 4 GB RAM, and 20 GB storage for any of the users, which is enough for quite a few experiments, but probably not enough for everything you want. So it's typically used as the first step to play around with the notebooks, to play around with data visualization, and then you may want to move further and have a community-specific allocation, which we also provide as part of the SLA negotiation and resource allocation process. This notebook service has many new features that were added recently. One of the features will be demonstrated at the conference on Wednesday, and this is the MATLAB integration that we worked on with MathWorks and enables the users to use MATLAB application and run MATLAB application in a scalable way on EGI resources. Let me show you a bit of statistics of who are using EGI and how the infrastructure is used. Here I have 3 statistics for you. The first is showing the total user base, around 77,000 users at the moment on EGI. And here you can see that more than half of that comes from medical and health sciences. Approximately the same number, 16%, comes from high energy physics and earth and environmental sciences, and then the rest is spread across the rest of the disciplines. If we look at the CPU consumption, which is an often referred metric in EGI, then here I have split between the high throughput compute and the cloud compute. The high throughput compute is much larger. So you can see it's several magnitudes larger than the cloud compute. And as you can see, is dominantly used by the physics, by high energy physics and astronomy and astrophysics. Meanwhile, the cloud, which is a newer and more rapidly growing infrastructure in terms of the data centers that participate, is more balanced, and it's used dominantly by earth and environmental sciences, by medical and health sciences, by different regional initiatives, but you can see here that many of the users on the cloud are in piloting or in interdisciplinary exploration at the moment. And let me move to another view of EGI, something that can be relevant for you if you are coming from a data center or if you are coming from an international community that already has some resources that you use. And in this case, you can look at EGI as a system, as a facilitator that can help you federate your existing resources, make your resources more seamlessly integrated, make your resources more seamlessly consumable by the scientific end users. And in this context, we have another value proposition, which we call the internal service catalog or portfolio that we offer for the members of the EGI Council, the members of the EGI participants who can use these tools to integrate their existing IT capacity. And the most important part of this catalog is in the middle, these technical services that includes a marketplace, an accounting system, different types of collaboration tools, configuration database, operational tool, a help desk, a service monitor, software repository, which all can help you integrate existing systems together, monitor the health of those services, generate accounting reports about the usage of the services, connect your users with the service providers through a help desk, for example. These services will have roadmaps and feature presentation session on Wednesday. And how we use this internal service portfolio. Again, let me go back to the Large Hadron Collider that I mentioned. And with the physics, the high energy physics community represented by CERN in the EGI Council, we have an agreement about the use of these different internal services. The Large Hadron Collider experiment and the community itself has a quite complicated data processing pipeline that starts from the detectors at CERN and then turns the data into final data products that are then consumed by the physicists. EGI, under an agreement with CERN, provides different services to this pipeline, including those internal services that I mentioned on the previous slide. So the WLCG infrastructure, the Large Hadron Collider grid infrastructure, is using the accounting, the monitoring, the help desk system of EGI. And under this agreement, we have a more complicated collaboration with the community. For example, we are coordinating the service delivery activities. We coordinate the service or technology lifecycle management. For example, the decommissioning of outdated technologies, replacing those with newer versions, a coordinated stage out of these technologies across multiple sites in multiple countries, development of new features and innovating new services together. And through this internal service portfolio and through the collaboration with such massive international communities, we already enabled or contributed to 2 Nobel Prizes in 2013 and 17, and we support different other types of science as well. You can hear about these examples, for example, from Stefano Bagnasco from the Virgo experiment, who will give a keynote on Wednesday, or from Sylvie Jessom from the environmental sciences climate research community, who will give a keynote on Thursday. And let me just close this presentation with a final word on a FITSM training, which is one service that we have in the EGI service portfolio, and something that we use to help both those who are in EGI and those who want to learn from EGI about IT service management. FITSM itself and the IT service management itself is an approach to help providers, IT service providers, reach high quality and user-driven IT products and to offer user-driven IT services. FITSM itself is organized into a set of requirements that define how organizations should operate their IT services to fulfill these user-driven and sustainable setups. FITSM itself has 85 requirements that are brought into different areas or different processes. There are 14 processes covering aspects of the service provisioning, things like how to define a service portfolio, how to operate services at the level required by customers, how to react to incidents, how to deploy changes in the services, how to manage capacity and releases. And by implementing these FITSM requirements means that you need to satisfy your processes and systems. You need to define your processes and systems in such a way that they satisfy the requirements. So again, just one example, that FITSM has 6 requirements from the release and deployment management area. And by satisfying those 6 requirements, you can say that your setup is FITSM compatible for release and deployment management. What EGI does is offers trainings for our data centers, compute centers, as well as for members of the broader EGI community, and help them reach the maturity with their organization and with their processes and services so they can be customer focused and high quality service providers. And let me finish the presentation with a bit of outlook to how EGI and the European Open Science Cloud relate to each other. Probably many of you already know about the European Open Science Cloud, which was defined by the European Commission as an initiative back in 2016 as a virtual environment with free at point use, open and seamless services for storage, management, analysis and reuse of research data across boundaries and scientific disciplines. The Commission organized the implementation of the European Cloud initiatives into different projects. And in late 2020, a legal entity, the EOSC Association, was set up. Since 2021, this EOSC Association leads or coordinates the development of the European Open Science Cloud through the different projects, different task forces, and other mechanisms that are in place. EGI participates quite strongly, both before 2020 or before 2021 and since 2021 in the setup and operation of the European Open Science Cloud. In the past 3 years, EGI coordinated the EOSC flagship project, which is called EOSC Hub, which laid down the core elements of EOSC, such as the EOSC portal, established a help desk, a monitoring and accounting system, and many other systems, including a service management system with documentation about, for example, how new services or entries can be added to the service portal, what the onboarding of new resources mean, how providers should react to incidents, and so on and so forth. EGI also contributed to the EOSC service portfolio with those services that I covered earlier, from the compute, data, security, and also higher level thematic services areas. Since 2021, we are no longer having the EOSC Hub project. However, there is a new flagship project in EOSC called EOSC Future. EGI is taking an important role, continuing to provide those core services that have been established in EOSC Hub, having a new project also called EGI-ACE, which is the EOSC Compute Platform project, delivering compute services and related capabilities for users of EOSC. We support different other thematic areas and thematic projects that set up and bring services into EOSC. And we participate, or the EGI participants more precisely participate in many national initiatives that bring national open science cloud nodes into the EOSC ecosystem. This EGI-ACE project is a flagship project for EGI since January. And as I said, is the compute platform project of EOSC. It delivers free at point of view services for science and education and innovation. And one message for you is that to tap into the EGI services through EOSC, now the EGI-ACE is the way to do that. EGI-ACE runs an open call for users, which is continuously open on the website, and with a cutoff date every 2 months. The next of such cutoff date or selection date will be on the 15th of December, when we will allocate the next round of capacity for those users and use cases that apply for the access of the EGI services through EOSC. And I would like to close the presentation with these 2 links for you. If you want to learn more about EGI outside of the EGI conference, then the publication section on our website is a perfect place to start. If you are interested in learning more about EGI services itself or using any individual service, then you can visit the service website on our page and either request access directly or submit a question to our support team. Thank you very much for the attention.